Okay, now we got done thinking. We get to start working. We design what type of port, and then we get to the drawings. We can change and rotate valve centers so that they line to aid in visualization. We can rotate the port to aid in droplet path. All right, I'm kind of a dumb guy. I like to look at everything. So when I'm making drawings, especially if I'm doing something in this case, I turn it so the valve centers are in line, because I used to do a lot of Chevy stuff. And it gives me an idea of how the distance from valve center where it crosses the plane of the bore is to the bore. It's a little hard for me to imagine, and I'm not that good at AutoCAD where I can do it at this. So then it begins to give me a real understanding of where I am compared to where we've gone over the years. If I was to go all the way back to that slide where the port was placed differently over the cylinder, as time has gone on, we have gone from being in the back to middle to forward. The engine's like in a Ford. If you look at it relative to putting the valve centers on line, the valve center has moved way away from bore now. When I do this, I also can begin to design how am I going to enter the cylinder for the in-cylinder motion and droplet path. So here, I can make all the different drawings before I ever decide that I want to make the engine. System-wide engineering. Directional ports like a long distance to bore, but not a straight attack. All right. If I could, I would actually thought about rotating the slide and putting these in line. But this is how the engine sets, the head sits in the bore. But if you look at the flow path coming in here and you figure these in line, this in-cylinder motion comes down and goes around the cylinder, but there's quite a distance between the center line of that valve guide and the bore. And if we look at it, that becomes important for our directional port and our flow path. Because in this engine, we have a very, very short stroke. This engine was created to make 800 horsepower. At that time, I wanted to design an engine. At the time, I was only making 700 out of 300 and some change cubic inches. I wanted to design the engine to make 800 horsepower. So we set off to do that at the time. And that's what we felt we needed to do. We needed a directional port so we could get the best flow path. There was no impedance on the droplet. We could get the in-cylinder motion for high burn rates. And we made all those calculations that I just showed you. If we had a straight tack to the bore, if we had left the port in the original line, a lot of times we have people asking me about the wetting, the wall wetting. Well, that's what happens. The droplets collide with the wall. They begin to coagulate, they clean the carbon off the piston, and you get a lot of wall wetting. The next thing is, manifold is a part of the system. Optimum roof and floor angles are provided by the right manifold. So the next thing we begin to do in our drawings is figuring out, from past experiences and RPM range, the manifold that we choose to use. So we had developed a manifold design that we liked, and all I do is stick figure it into AutoCAD so that I can figure out the floor and the roof angles. Once again, the reminder, the outcome. The finished pictures always give a good idea of the outcome. Don't compromise on perfection. Draw the port based on all previous criteria and modify the head to fit the port. Don't modify the port to fit the head. Try to make the perfect head. And so when I was doing this, that's exactly what I tried to do. With all the previous criteria that I just led up to, I designed this inside of a Ford deleted service Yates casting. And one of the fellows who was very helpful was Jim Novak, who spoke here several times, and they got me some deleted service castings. And all the casting work you saw in the welding work we did in-house. The three-quarter view shows minimized plenum. Carbs and droplets hate extra space. Minimize total volume from valve to butterfly. This is especially important not only in this application, but when you're looking at throttle response for circle track and other ones. One of the other components that people forget about is the intake track has volume from the valve to the butterfly. And the engine accelerates and the carburetors are more sensitive and the droplet distribution is better at a higher speed. So minimizing total volume is really important depending on the range and your ability to carry through gear changes in drag cars, for instance. Droplet path starts at the plenum. Side view shows the move port location. All right. To give you an idea how much was added to the top of this head, I added over an inch of material to the top of these head so I could get the ports where it needed to be. The original port laid over here, and all that material was added, and we put it over there. It was quite a lot of work to take an idea and begin to fabricate these heads. I had to learn how to do metal fabrication. That was all part of doing it. What I find is okay, I have these ideas of making things perfect, and then what helps me is learning how to get to that point. What are my shortcomings to allow me to finish this project? So it's been a pretty good learning thing. Okay, once again, no wasted space, total efficient package. You know, this was a manifold I put together just a few months ago. To give you an idea, I mean, it's been finished since then, but because of my accident, I didn't get a chance to take another photo to show you a more current photo of this particular manifold. I apologize for that. Small to no plenum to corner port corner radius. Let me say it again, please. Small to no plenum to port corner radiuses. Big droplets like big radiuses, and wetting that goes on in the plenum should be broken up by small or no corner radiuses. You can make manifold flow significantly better by putting a huge radius on this. But we also found that there's some cases this manifold was really designed for drag racing, and there is, no matter how much you do, some wetting going on in the plenum. Well, once it got to the corner where it was going down through the plenum, that we would know the EGTs would go up. There was and it didn't affect the power performance of anything, but the airflow at all. But the power went up, and the brake specifics improved by reducing corner radiuses. And when I finished this corner radius to a manifold that we currently use, it's nothing more than a fairly rolled edge. We don't radius it hardly at all, and that's proven to be very successful. Say ah. Think as if you were a fuel droplet in this frame. No path change or collision with anything. So as we've gone down through this now, and we're beginning to not only realize we've constructed this engine, but we're beginning to get a feel for how the droplet thinks. You know, I think it had the ability to think. As you can see, I love tangent walls to the bowl. And as we were saying, I heard Harold say last night about Rick from Rare Morrison. He had a very good presentation here a couple of years ago, what they have on videotape that I would recommend. And Rick asked me about his presentation we've done, but he realized this was done 7 years ago. This was the idea that we were going, because with generous corner radius and working with a droplet path. Measure twice, cut once. Once we've done the original one, we want to recheck the area for any wall changes again, which doesn't really show up that well. It's a little washed out there. No headache here. Chamber is an aid to droplet path, not a block. And valve as well changes the valve as well. All right, I didn't put the valve in here because I wanted you to see that the spark plug and the chamber are aids to how the droplet, once it goes in cylinder, is not either impeded by the chamber or having to chase the chamber. It becomes a flow and droplet aid to the in-cylinder path in a directional port. The other thing that we're working on in the short term, when we're using directional ports, we're actually beginning to make them more abrupt and sharper. What we had learned from some of the import directional ports is they leave them completely sharp. And a lot of times when we're using the valve as a directional aid, this is not now where it's in the flow path directly, but it becomes part of what supports the flow for the in-cylinder action, is you want the flow to break away from the short term rather than try to follow it, so that you can keep the charge together. So we've actually begun to make that fairly abrupt. To show the chamber without the bore is incomplete. One needs the other. The drawing realized the total package aids in visualization of flow path. And this, you can probably see it better than I can. Once again, we put the cylinder. This is actually the engine that goes on with, and we have the photograph of the entire engine because it really gives you an idea. I try to visualize as much as I can because when I'm away from my work and I'm doing my thinking, that's when I really begin to understand how the engine wants to run. And with that, it reminds me, because I like to also let you know where there's good information. Pat Bear, who works at Chrysler, is connected with a lot of dynamic programs. And I always suggest to anybody that anything that Pat Bear's name is on, watch. Their programs are one of a kind. So we've done a lot of that, and I think if you got a chance to look at some of his videotapes, it would be a great thing. Reengineering lifter positions. To take advantage